Hi, everyone. Really happy to be here. It's my first time in Vue.js Germany, and also my first time in Bonn. So thank you very much for having me today. I'm going to try to put this on full screen, maybe. I'm using a slide dev, as a lot of people does nowadays. So I have around 10 minutes to tell you about Tres and what's hot on TresJS version 4. OK, so this is my talk today. My name is Alvaro Saburido. I'm a developer experience engineer at Storyblock. I'm originally from Venezuela, but reside in Barcelona. There are my links if you want to say hi or show me what you're building. Always happy to hang out. Yes, I'm that guy. I used to have the white hair, but I tried not to damage my hair anymore, so now I have it long. But it's the same person. So how many of you know what Tres is? OK, more than I expected, because it's honestly a really young library. It has only 2 years old. It's going to be in November. And what TresJS is a custom render in Vue. It's a Vue custom render for 3D. So normally, when you're doing 3D on the web, you're using TresJS under the hood. And what Tres does is that it gives you a way of doing scenes, 3D scenes declaratively by using components and composables. It's called Tres because I'm Venezuelan, so Spanish speaking, and also because the French word was already taken. So I'm really happy because it's almost 2 years from the creation of TresJS. I originally did for my portfolio, which I haven't finished it yet. So I created a library to be able to use 3D on my own portfolio and never finish it. So here is TresJS around like crazy numbers. I was checking the numbers yesterday. I'm really surprised I got like 100K downloads monthly. So I'm pretty happy about the community. And you can get started by just installing TresJS Core and 3JS as a pure dependency. We also have a playground, like a single file component playground that you can start playing with it. If you see here is the code. So plain Vue, OK, with the magic of 3D. So we are already in the version 4. And now that I see the version 4, we have iterated a lot and obviously created a lot of breaking changes. So we collected a lot of feedback from the first iteration, like last year. So we ask users, OK, are you building things with 3D, with Vue, with TresJS? And we collected a lot of the feedback. So there was a lot of performance issues. Also, a feature request was on-demand rendering. We're going to get there. A lot of TypeScript issues because, of course, TypeScript. Memory leaks, because we are talking about really performance-heavy operations. And event handlers on primitives. We're going to get there in a moment. So on-demand rendering. We did on-demand rendering. We did refactor the whole event system and propagation logic to be more similar to what you do in the DOM. We added event handlers to primitive. I'm going to talk about that later. The object prop on primitives is now reactive. And we work a lot on the disposal of resources. But the most important part of the V4 was a new render loop. Because when you do 3D, you are creating an image. And you have to iterate that every frame per second to create a new image to show an animation, like how animation movies or games work under the hood. So we created a new composable that does it in a better way. And of course, a lot of bug fixes and performance improvements. So on-demand rendering, really quick. When you have the Tres canvas, which is the canvas component that draws everything, now you can tell it not to render whatever there is no need for it. So if you pass a prop that is called on-demand, by default, it will render all the time. But if you put on-demand, it's only going to render when it needs to render. So there is an update on the scene or one of the props changes, it's going to apply the render. So here in the video, if I use the on-demand rendering, in the top, you can see that in the low point, it's not rendering. And whenever I change the camera, it starts rendering. So this is huge for performance, because I'm stopping the rendering to happen, which is a heavy operation, whenever we don't need to. Then we have manual invalidation, which is another level. So instead of having on-demand, we let the user decide when they want to invalidate the frame. So they decide when to render the scene. And you can do it by using the useThresh composable. And whenever you see a change, you invalidate. Then we refactor the whole event store and propagation logic. What is events? You click on a 3D object, you need to fake that object to be clicked. So if you want to change, I don't know, the color of it, we had click, pointer move, like a hover effect on the 3D elements, pointer leave, and pointer enter. But for the before, we added context menu, so right click, double click, pointer down, pointer up, wheel, and pointer missing. So this is really different from the VDOM because you use the camera to know which components are in front of the camera and need to propagate events. So if I had these three tables right here, if I click in the first table, it's going to propagate onto the last one because it's where the ray tracing of the camera is going. But we added the option to stop the propagation. So if the first table say, hey, we are not going to propagate the effect, if I click there, the other ones are not affected. So it's more or less like this, OK? So this is a video showing. So we have this cube, and if you click it without the event propagation, you see that they all change color. But if I enable the propagation, it doesn't. So OK, 4 minutes. Let's go. Primitives. You might think of primitives like this, but it's essentially being able to programmatically create a 3D object and add it to the scene without the view component. So you can do that with the primitive and passing it with a prop object. So this is amazing for models, because then I can import a model from internet or something that I created in Blender, add it to the scene with just one line, and a composable called useGLTF. This is not necessarily important. It's just making it reactive. So if I click here, for example, I can change the whole object. Really useful for gaming. If you want to change the character, I don't know, armor, or do like a Baldur's Gate kind of editor. And we have also added conditional rendering. So we can use the beif to show or not the component on the view. Then we added event handlers to them, which is kind of cool, because before you cannot click on the objects. Now you can do it in the models. You can click the different parts of the model. Especially useful for, we have some users that were doing like architectural stuff. So they were building like a house, and they needed to interact whenever they click an object to drag it and put it, and this made it possible. So whatever you add, like in plain view, you add the click event handler, then you can call the function and do something with it. Memory management, to be honest, is really boring, and we just launched. So I'm not going to talk about that. We just basically did a lot of improvements there, GPU and CPU. You're going to be living in that. We did a lot of devtools improvements. We're really excited with the new Vue devtools and what it has to offer, because it's going to allow us to add all the developer experience that plain TresJS doesn't offer, because it's an imperative code. With Vue, we had the devtools, so we managed to add all the different components like the camera, the ambient light, and you're able to edit them in real life. You are able to move a component inside just by using the devtools, and that's powerful. So we're rendering all the info, like how many triangles, how many vertex, everything in the devtools, and we added also shaders. Shaders is basically materials, how they look, if they are shiny, if they are opaque, things like that. So you can search the scene 3D objects by name. So we added the search functionality if the scene is big. But I'm going to take the last minute to talk about the use loop composable. So before this, we have a use render loop. And whenever this render loop iterates, it triggers a new render. The problem was that as a user, you didn't have access to the state of Tres. So you couldn't get like the previous camera. You couldn't get what objects are inside. There was no possibility to add order. So if I wanted a callback to be before the rendering or after render, it was impossible. And there was no way of taking over the render loop. So we did a lot of like mathematical stuff, but basically we created something on before render, Then the rendering of the frame happens, and then we have triggers post-calculation, so for physics, for post-processing and stuff. So the way you do it right now is that you use the use loop composable, and you had 3 methods. One is on before render, so this is going to happen before you render, animations, moving a camera, etc. Then you have the takeover, where you take the responsibility of rendering, and that's where you get the state. You get the render, the scene, the camera, and you can render yourself. And then you have callbacks after the rendering. You can also pause the loop. So I'm out of time. Let me just quickly show, like, we have a cookbook now in the documentation with real examples. So if you want to try Tres, you can go there and see like examples of real use cases and how they're built. And I want to thank all the contributors that make it possible. We are around 50 contributors and 4 persons in the core team. And without them, it wouldn't be possible. I also want to thank all the sponsors. Also, StackBlitz just joined it as a sponsor because of the Conf, the collaboration we did. So if you want to collaborate and help us, we have an open source GitHub sponsors collective. So thank you very much.